Welcome back, class. I hope everyone is having a great day. Today we move on to finding the domain of composed functions. Okay, so a little bit different than when we were finding domain with operations of functions. And really, what we need to do, there's a couple of things we're going to have to consider. And before we do that, we have to remember that when we talk about g of x, I'm going to use the word little. That's my little function. And then f, the f function, is the big function. Okay? So the first thing we have to understand is that because we are putting x into g of x, well then we definitely have to worry about the restrictions of g of x, right? I can't put something into the g function unless it works, unless it wants to work. So we definitely always must consider the domain of our little function. Alright, so we always have to consider the domain of our little function. The next one, and we can't just say we need to also consider the domain of our big function. It's a little different than that, and the reason is because we're putting g of x into f of x. So it's not that x has to obey f, it's that the entire function, the entire g of x function, has to obey the restrictions of f. So in this case, we're going to say the little function must follow big function restrictions. Okay, so again, I know that's very wordy. I know maybe that doesn't make sense right now. When we get into some examples farther down the page, hopefully it will make a little more sense. Alright, and again, I say hopefully down the page because this first one is going to be nice and easy, but I want you to kind of see how I'm setting this up. Okay, the other thing that I want you to recognize is I'm not going to compose this, right? This says f of g of x. So maybe I'll still write it just so I remember what I'm looking for here, but I actually do not need to compose this. I don't need to put the g of x function into the f of x function, which is kind of nice. All right, it'll save us a little bit of time. So when we start to get our domain, when we want to get our domain, we have to consider our two rules. Our first rule is we have to have the domain of our little function. Well, our little function is g of x, and if we notice, there's no restriction on g of x, right? 2x plus 3, this is in the numerator. It's not a radical, it's not in the denominator, it's not a radical in the denominator, so we know that the restrictions on g of x, or there aren't any, right? So we have all real numbers. Now, what we say, g of x must follow, whoa, I can't spell, follow f. Alright, so that's a follow, geesh, follow f. So let's take a look. We know that if there are any restrictions on f of x, g of x must follow them. Well, we look, let's see, numerator, okay, there are also no restrictions on f of x, so this is also all real numbers. And then what we do, guys, is we put it all together. Okay, we put it all together. We say that from g of x, our domain was all reals. From g of x having to follow f, it was all reals. So our domain in this case is all real numbers. As we move on to another one, the next one, let's see what happens now. Okay, let's see what happens now. So it's already written in the nice form. We can see that what? G of x is our little, g of x is our little, f of x is our big. Which means when we start this domain, and we go with our first step, we have to first look at the little function. The little function says g of x is equal to 4x plus 1. Again, there are no restrictions here. No restrictions on our little function. However, when I write my next rule, that g of x must follow f. Well, now let's take a look. In my f function, with my f function, I know that x plus 2 has to be greater than or equal to 0, right? So x must be greater than or equal to negative 2. Well, that means that my g of x function, I basically am saying, well, my g of x is now like my x. G of x must be greater than or equal to negative 2. Do you see how I did that? I got the domain, and then I just said, well, now g of x has to follow that restriction of greater than or equal to negative 2. So now when I plug in, right, I know g of x is 4x plus 1. That has to be greater than or equal to negative 2. And I start to solve. All right. So I now know that x must be greater than or equal to negative 3/4. Well, basically, guys, what we're doing is we're kind of combining these two ideas, okay? This is my domain, or my restrictions from 2, from the second step. This was my domain, or there's no restrictions, from my first step for g of x. So when I combine these two together, I just say that my domain is x must be greater than or equal to negative 3/4. And hopefully that makes sense. If I have all real numbers here, and I have x must be greater than or equal to negative 3/4 here, well, where's the overlap? Where are both of them occurring? And it would be in this section. Okay, so let's keep moving on. Let's see. Okay, a little bit tougher now. A little bit tougher. Oops, sorry. Okay, so one thing that you could always do that might help, sorry, I can't get this camera right. Okay, one thing that we can do that might help out is just kind of get our restrictions from the very get-go of f and g. It might speed up the process a little bit. All right, so we know that because we have 1 over x plus 2, our f of x function would be, or sorry, the restriction would be x cannot equal negative 2, right? Why? Because x plus 2 cannot equal 0, and we move it over. Thinking about it in the same way, but with our other function, I also know that x cannot be 1. So now I have those two restrictions. We have to move on, and we have to remember that I don't just want my g and f restrictions anymore. That would have been more like when we were doing operations. I need to use my new rule. I need to see that g of x is my little function. So yes, I must use the domain, or the restriction, I keep saying domain, the restriction from my little function. So definitely x cannot equal 1. However, when I move forward, what do I say? I now say g of x must follow f. So if I know f says that my restriction cannot be negative 2, well then I know what? That g of x cannot equal negative 2. So I plug in 4 over x minus 1 cannot equal negative 2. Oh, I'm going to make that over 1, and what am I going to do? I'm just going to cross multiply. So if I do that, what do I end up getting? I end up getting 4 on the left, and then negative 2. So negative 2x plus 2. Please remember to distribute. That's still a common error, and I want that to stop. Alright, so when I go ahead and I solve this, I get 2 is equal to negative 2x, or x is equal to negative 1. Alright, so now I have to put everything together. Oh, sorry guys, my bad. All of these are not equal to's. Ugh. Okay, I now know my two restrictions. Think about that. If it's just two places where I can't be, I'm going to start by saying the domain is all real numbers, except for what? X cannot be, and I'm just going to go with plus or minus 1. Okay? So again, the little function domain restriction will always work, and then the second part is you have to kind of figure out how that little function follows the restrictions of the bigger function. Let's try part B. Okay, so really all that's happening here is we're switching, right? Before we said g was our little function, now we're going to say that f is our little function, which means f function. F function, we said that x cannot be negative 2. So that's what we write. And now instead of saying g of x must follow f, we say f of x must follow g. And we do that because now we know that our f function, or 1 over x plus 2, is what? What do we have to say? Is not equal to 1, because that was our restriction from the g function. So, f of x must follow the same restrictions as the g restrictions, or 1 over x plus 2 cannot equal positive 1. Alright, what happens to solve this? I'm going to have to cross multiply. So 1 times 1 is nice and easy, that's just 1. 1 times x plus 2 is just x plus 2. And then I'll move the 2 over. So x, I keep doing it. X cannot be negative 1. I now have my 2 restrictions. Remember that these are just individual values that our domain, that our domain cannot be. So we're still in an all real numbers situation. However, now x cannot equal negative 2 and negative 1. Alright, let's move on to even something more difficult. Challenging, I should say, not difficult, challenging. Okay, here this says that we don't want to just state the domain. We want to actually find f of g of x and then state its domain. Okay, so that's going to look a lot like what we've done in previous videos. So I'm going to rewrite f of g of x, f of, and then my g function, or expression, is the square root of x minus 2. So what do I have to do? F of x is x squared plus 4, right? So I need to say this is the input squared plus 4. Input squared plus 4. So input squared plus 4, and I have x minus 2 as my input. Well, this is nice, right? Square root and squared cancel, so we're just left with x minus 2 plus 4, or x plus 2. Alright, so this is f of g of x, which is great. However, what are we thinking here? If I look at this, I say there's no restrictions on the domain, all real numbers. If you said that, you would be incorrect. Okay, we need to go back and we need to do what we've been doing. So, 1, we take a look. Our inside function, or our little function here, is g of x. And g of x, we have to say x must be greater than or equal to 2. So x must be greater than or equal to 2. Well, we also know that g of x must follow f. Well, what do we think here? Okay, f of x, x squared plus 4. This isn't all real numbers, alright? There's no domain, there's no square roots. Alright, we're all good here. So this just means all real numbers. Well, we have to combine these two ideas now to finish up the problem. We know from our little function that x must be greater than or equal to 2. We know from number 2, well, that g of x could be anything. So what is the least, or the most restrictive, I should say? Boom. X must be greater than or equal to 2. We move on. This next b is basically the same thing, but flipped, which means it'll be completely different. My bad. Oh, I should have changed to red. Alright, g of f of x. Okay, so now what are we saying? F of x is x squared plus 4. And we know that our g function states what? Square root of the input minus 2. So square root input minus 2. X squared plus 4. Alright, if we keep moving on, let's see. X squared plus 2. Alright, now please be careful. You cannot do any more with this. We're done here. Why are we done? Because this is an entire quantity. We cannot take the square root of x squared plus 2. So we finish right here with g of f of x. So that's good. Now we move on. Okay, now we move on and we find our domain of this composed function. So f of x is our little function now. F of x is our little function, which means that is our first restriction that we have to find. Well, f of x, no restrictions, all real numbers. So that's a good way to start. Now we know that our little function, f of x, must follow g rules, the g restrictions. So we know from above that our g restriction was that x had to be greater than or equal to 2, which means that f of x must be greater than or equal to 2. Let's see what happens here. We plug in x squared plus 4 must be greater than or equal to 2. I have a quadratic and it's an inequality, so I'd probably want to move the 2 over and try to factor this. So x squared plus 2 is greater than or equal to 0. Hopefully we remember we cannot do this. Okay, we can't do this. If it was x squared plus 2 is not equal to 0, you would move the 2 over, you'd end up getting x squared is not equal to negative 2, and you can't do that, right? So for this, we really have no solution, why do I care? All real numbers then, right? If there's no solution, then there's no restriction, which means all real numbers. So when we put these two together, well, we have all reals. This one's nice and easy. All reals. All right, almost done. Last problem. Whew, almost there, guys. All right, so we have one more. We are again finding f of g of x first. So first I want to do f of, alright, so f of g of x, and I'm just going to replace g of x with the g of x function, square root of x plus 5. Let's take a look. We now know that our f function is 1 over the input, so 1 over input, and we know that our input is square root of x plus 5. At this point, guys, I'm completely okay if you want to leave it like this. A lot of you guys that were taking summer classes or even just Algebra 2 with teachers that were sticklers on this would understand or realize a lot of the times we don't like to have a radical in the denominator. We say we want to rationalize it. And so if you did want to do that, you're more than welcome to. We would do that by multiplying both top and bottom by x plus 5. Which means that our result would be, well, 1 times, so we have square root of x plus 5. And this would just mean that the radical bars would cancel each other out. Sorry, that's a 5. Alright, so guys, I'm more than okay with either answer, f of g of x. Both of these answers are perfectly acceptable to me, whatever you kind of feel. Now, we want to also get its domain, so we're going back to that two-step idea. 1 and 2. And really, guys, what I'm going to ask you to do first, figure out what the domains are individually. So this one's nice and easy. X cannot be 0. Here we have x plus 5 must be greater than or equal to 0, or x must be greater than or equal to negative 5. Okay? So let's take a look. We know that we need, our first step is to find the restrictions of our little function. Well, our little function is g, which means this is the restriction I need to start with. X must be greater than or equal to negative 5. Now, the next step. g of x must follow f. Has to. And we know that f cannot equal 0, which means g of x cannot equal 0. When I put, or replace I should say, g of x with square root of x plus 5, well, this is pretty nice. How would I solve this? Right? Wouldn't I just square both sides? So this would become x plus 5 is not equal to 0. Lastly, x cannot equal negative 5. So this one is actually a really good example. I have x is greater than or equal to negative 5. I also know that x cannot equal negative 5. Alright, so you guys have to kind of think about this. Even though this one is saying that x cannot be greater, or sorry, x has to be greater than or equal to negative 5, this guy right here is changing that. This guy is saying, well, no, I'm okay if x is greater than 5, but it cannot equal negative 5, which means we have to finish by writing x is greater than negative 5. Alright, so that was a little bit of work on both composing functions again, and then finding domain and range of composed functions. Have a good day.